All right, welcome everybody. Today I'm going to talk about cloud AI services. So really this is about understanding how you can take advantage of artificial intelligence in the cloud and engage with AI in your own way at the level that you're at in your journey with machine learning and AI. So we have a wide variety of ways to engage. We have APIs where we have pre-trained models for vision and natural language capabilities where all you need to do is call our APIs, pass in the data that you want analyzed and get some insights back. We, on the other end of the spectrum, have a platform for building custom models with a great range of capabilities from development to serverless hosting and so on and so forth. And somewhere in the middle, we have AutoML that allows you to build custom models without doing a lot of data science yourself. So we'll look at all those different choices, and hopefully coming out of this presentation, you have a good feel for how could I potentially embed some artificial intelligence into what I'm doing in my code. So the agenda is starting with selecting the right use case, just a little bit of background on where these tools can be appropriate and useful. It starts with solving the right problem. Then let's discuss the APIs that, as I mentioned before, give you a out-of-the-box insight into the type of data you're working with. Then we'll talk about custom model development, AutoML, the platform, and then we will do a demo. So let's start with the use case. So we've seen that there are a few categories of machine learning that we see over and over again and get a lot of value out of applying ML to those. So the first one is predictive analytics, which is essentially looking at historical data and, doing what humans have tried to do since the beginning of time is try to tell the future, right? So with AI and ML, you have some useful tools to help you do that that can look at various patterns in the data, things that might not be obvious, and use that to forecast, a day ahead, a week, a year ahead. Take multiple time series, combine those together to look at ways that they interact, and so on and so forth. And so some of these different use cases might be things like fraud detection, or maybe looking at when some equipment might be about to overheat but hasn't quite had a problem, looking at, demand forecasting, all kinds of different scenarios, just basically looking at previous data and figuring out what might happen next. The next category would be around unstructured data. So taking wide volumes of data and trying to make sense of that. In many cases, you might not have a ground truth for that data, meaning you may not have classes of information, but you could cluster that data. You could kind of take it and do some similarity analysis and figure out, what buckets this data might fall into. And in other cases, you do have some classes or ways that you can sort this information in a more structured way. Automation is another huge use case. So looking at the workflow in your company and thinking about ways that there might be a step in the process where it's tedious, error prone, and an AI model might be able to fulfill a step or two out of that process. You see some examples here: scheduling, counting, triaging, things like maybe you see where you automatically get directed to the right type customer service grouping based on the type of issue. We're automatically looking at user reviews and flagging something that requires review. So in basically any manual steps, seeing if we can automate that. And finally, personalization. So how do we create a more targeted experience by looking at the characteristics that we know about the user and trying to help segment and target and make their experience more useful for them. So that's not an exhaustive list, but that gives you some ideas of where you could apply ML. And so now let's kind of look at, from a product perspective, where do we start? I'm not going to go through all these, as we call them hexagons, the product capabilities, but this is sort of a workflow around what do you do? So if your data happens to be trained on the same types of inputs and labels are categories. We'll talk in more detail about that later. And the volumes of data, fit into what the out-of-the-box tools can provide. What you see on the right side is a fantastic way to get started. We have some very robust APIs for all these different categories you see here: vision, natural language, looking at text, translation, so on and so forth, and dialogue flow for chatbots, contact center interactions, things of that nature. On the left side is where you have the build capability. So you need to build something yourself. Starting at the top, you have the various AutoML products that cover many different data types now. And then the platform services where you would need to build your own model. And that covers everything from the data integration to building the model to deploying it, and so on and so forth. And at the bottom, you see there's also a wide variety of infrastructure capabilities. So using specialized chipsets for AI, such as the TPU chipsets, GPUs, and so on and so forth, on a wide variety of ML frameworks. Okay. All right. So I'll just keep going. We have a small, we have about 45 minutes, so I want to kind of keep getting to the main point here. So let's dive into pre-trained models with APIs. So some of the common tasks here that we're going to discuss are, vision and natural language. There's some other capabilities around translation that I think are fairly self-explanatory, but we're going to cover how to write some code that's going to integrate to these surfaces and how you can use them. All right, so let's start with the natural language API. So here you see what the website looks like, where you want to enter some text. It's basically a demo application. So we'll go ahead and we can take a look at that. If you go to the well, actually, I don't have the link here with me right now. But if you go to the Cloud Natural Language site, you'll just enter whatever text you want. And here you see the different tabs, right? And each of the tabs shows capability coming back from the API. So the first you see here is entity extraction, where you can take any text and it's going to flag what the most important objects are from the text. And you can go and look at that and look at the the salience, basically how important that was in the overall text itself. And then you see a variety of other things: sentiment analysis, syntax, identifying parts of speech, and then categorizing the text. So, a lot of things are coming back from any text that you pass into this API. So just some quick examples here. So we took some New York Times articles just to kind of put them through the tool and see how they match to the predefined categories. So this comes back to that idea of, if our out-of-the-box categories work for you, then these APIs can be a perfect choice, right? So let's see what these map to. So, if you look at this, it generally, looks like it mapped pretty well to some useful categories. But again, if you had a more specific sort of niche category, you might want to use our AutoML or building your own model with our platform. So how would we integrate to these APIs? So here's an example of a command line integration with curl. There's a little bit of authentication, and then you see that you're passing in the text itself. And then finally, at the bottom, the REST API endpoint. So you're calling the classify text operation. And that's basically it. And so you're going to get back some JSON that will describe the objects. When we get to vision, you'll see a little more detail in what the return looks like. But it's as simple as that if you want to integrate that into your applications. All right, now let's talk about vision. So vision has a wide variety of use cases that you see here. You see everything from, looking at, object detection, what's in a picture, and labeling that, to OCR, pulling out words from the images, detecting landmarks, so on and so forth. Product search, so looking at maybe your catalog of products, and so a lot of great things you can do with the Vision API. So let's take a fun example here. So here's a sort of attraction that we put into the Vision API, and you see what's coming back here. So first it thinks, it's a landmark, which is true, and then place of worship. Okay, I can kind of see that. And you can see the various labels and their probability that it gives back to you. Okay, so that's kind of the main capability. But depending on the picture, it can provide a lot more levels of detail into what's available. So the next thing it could show you is emotion, right? If it detects that there's a person in the picture. So here we see, not a lot of emotion, but that there's headwear, and it kind of gives you a confidence on that. OCR, right? So we talked about that, being able to pull out text to the image. It can do that as well. And then landmark detection, so it can triangulate those results with the Google Maps capability to see where might that picture be. So a lot of information that you can get out of that API. So let's try a couple other examples and show how you would use the API to get that information back. So here's some older kind of nostalgic pictures, again, from the New York Times. Let's take a look at what the API says about them. So here's a Python example. So with each of these different APIs, I'll use different languages, so we can, depending on whatever is your preference, we'll see how to do this. So you import the Vision library, you instantiate a client, and you point it to an image in a storage bucket, and then you're just really going to invoke the label detection API and pass in that URL. Simple as that, and you're going to get some labels back. And so the JSON that comes back, rank orders the various objects that it finds in the picture and gives you a score for each of those. Right, so that's the Vision API. We showed you kind of one slice through that. Again, a lot of capability there. Now let's look at the Video Intelligence API. So this is similar to the Vision API, but it's for video. So really it's about looking at a series of images, all the different frames and how they relate together. Again, similar capability. You see here, it can do object detection, bounding boxes, so on and so forth there. And you can see here the in JavaScript what you might do. So you can instantiate the client pointing to a file, and then invoking the annotate video operation. So yeah, there's a set of SDKs that makes it easy to directly integrate to these different services. So what you get back then would be a set of labels. You see there in the bottom the comment. So here, for example, say that there is a dog in the video, you would see that that dog entered the video at 3 seconds and exited at 5. That's the kind of information that would come back from that API. All right, so we talked about standard tasks where the taxonomy, the types of objects that you want to find and discuss, analyze in your data is sort of standard. If you want to do something different and specialized, let's now kind of shift the conversation to how to handle that. So just to kind of put an analogy, we always have to have cats and dog analogies here when we're talking about machine learning, right? So with the pre-trained model APIs, you could answer a question like this: is this a cat or not? Pass it to the Cloud Vision API and get a description back, and you see 99% probability, yes, it's a cat. And of course it does way more than that, but just trying to provide a simple example here. Now what if you're trying to ask the question, what breed of cat this is? That might not be something that is, super common of a use case in the APIs. And so you'd have to write your own model to do that. So let's walk through all the steps required for that. So here you see kind of a simplified workflow, kind of steps 1 through 7 around what it takes to do AutoML. And the reason that I want to show all these different steps is to show where does AutoML fit in. It doesn't do everything for you, as we'll see. It does a lot of key steps, but let's look at what it does, what it doesn't do, and go from there. Okay, so first, we've identified the problem, identifying the breed of the cat. So next, let's gather and pre-process the data. So it's key in any machine learning problem to have a wide variety of data for each class, right? So if we're looking at different breeds of cats, we'd want to make sure that we have enough variety in those pictures and enough volume, and as much as we can have balance across these data sets so that we have a similar number in each of these different categories, right? So, with enough diversity in each of these different data sets, then it's going to notice the most important characteristics and have the most accuracy when you apply the model. So you're going to have to gather that data. The next thing you might need to do is to split the data, right? So typically you would divide it into, say, a 80-20 split, where you train your model on that 80% of the data and you hold out 20% of data that the model never sees, right? So you can have a objective evaluation of how well it did. You never want to test on what you trained as kind of cheating and that you're starting to memorize the information. So you want to see what happens when you apply it to information that's never been seen before. So then you might write some code to build that model. This is just an example of how you do this. Is actually a more complex type of model called a convolutional neural network. We'll just kind of walk through a few different screens here of what you might do if you were to program your own model. So you'd import some various, say, TensorFlow packages, a library for neural networks, and then some different types of layers for that neural network. You'd import that. And then here we're using TensorFlow's basically sequential API. So what this means is that in our neural network, we're adding layer after layer here. So you kind of say add. Each time you call add, you're adding another layer to that neural network. And we won't get into all the specifics here, but the net here is that we are in a convolutional neural network. You see kernel size 3.3. You're taking this 3x3 filter and you're sliding it across the picture, and you're trying to find that signal in those pieces of the picture, right? And kind of making sure, again, you're not memorizing, you're looking at applying some transformation to that sliding window to really capture the essence of what's in that picture. And then, you're doing some things like eventually, as you go through this network, we don't have that visualization that shows all the numbers of units and layers. You end up at the very bottom here where it says num classes with a probability, and that's where you see action equals softmax, which means 0 and 1 for n number of classes, meaning say all the different breeds of cats you had were 100, it's going to tell you, okay, it's 99% X, 1% Y, and whatever for the rest. So that's how you would build it by hand. Not a lot of lines of code, actually, and with the TensorFlow Keras framework, it's becoming easier and easier. And a lot of these models are now in a TensorFlow hub, so you don't necessarily have to even write some of this yourself. You can use transfer learning, you can use an existing model, and so that's what it would take. So that's building the model itself. Now, how do you train the model? So there's, you would call the fit method that takes the training data that we described before, and then some test data, and some parameters, the batch size, the epochs, the number of times you're going to pass through that data, And then finally, you would evaluate the model and you'll get a score back. Okay, so you've got a model. You can deploy it in a number of places. You could host it in the cloud, and we'll talk more about that. Basically very easily providing a REST endpoint that wraps your model so that you can pass in parameters to it, receive that prediction back, and you don't have to worry about scaling it. You don't have to think about any of the infrastructure. You literally just submit that model, you version the model, and then the APIs are provided for you. Or you could deploy it on device, which is another common scenario if you're doing any kind of mobile or edge work as well. So with that model, how do you use it? It's as simple as calling a predict method on the model. So with a set of inputs, you call predict, and you're going to get that set of probabilities coming back to you. So I know I'm kind of taking like a image processing kind of information here and trying to condense it into a few slides, but really this should give you a quick overview of the process for building it by hand. So we'll be able to now look at, with AutoML, is there a simpler way? How could we potentially automate some of those steps, right? So let's make Google do it for us. So Cloud AutoML takes that training data and works with a few different steps of the process, right? So for train, deploy, and serve, it can do that all for you and then generate predictions with the REST API. So the steps in the middle around, splitting the data, building the model, training it, and deploying it is what's covered by AutoML. So you still need to gather the data and potentially pre-process it. It does have some feature engineering built into AutoML, so it can take fields for dates and maybe split them by, is this a weekend? Is it a weekday? If that provides more signal in your data, it might look at, all kinds of different ways, numeric manipulations of the data to kind of auto feature engineer and create new variables out of the data you already have. That said, usually there's some work required to take raw data that was in a transactional database and prep it, consolidate it a little bit so it's ready for machine learning. So that part's still required. And finally, then you'll have an API and you can make predictions out of it. So let's look at applying AutoML to some different scenarios. So if we wanted to create an object detection scenario where we're predicting what piece of clothing somebody's wearing, this is kind of a fun example that our team was working on as a learning exercise. So we started with the labeled data set, right? So we went to Kaggle, which is a data science community where there's all kinds of great ways to learn about data science and competitions and so on. And they've also got great data sets. So we wanted to look at their e-commerce data set to just get started to build our own clothing detection model. And so when we looked at the pictures, we started with all of these great images and thought this would really accelerate our project. But we ran into an issue in that these images didn't really match up with what we were seeing in reality. Everything was so nicely manicured, with this white background. There wasn't the shading, it just wasn't giving us the accuracy that we were looking for using this particular data set. So we decided to do it ourselves. So we used a service that's available on Google Cloud called the data labeling service, where we could pass a lot of pictures we took ourselves, and we'd come back with a spreadsheet of all the different pieces of clothing that were in this picture. So it's a great way to take data that's not labeled and turn it into a supervised learning problem. And so how this might work is, we had some of the team members, just pose, we took pictures and different outfits and things like that. And then we provided annotation instructions, right? So every problem is different. You can't just sort of say, hey, here's my pictures and expect them to be mind readers, right? So you provide specific instructions, things like how many items do you want selected in each picture? What should they look for? Did they want to add bounding boxes around the items or not? And so there's, instructions in the docs that explain what to provide in this this instruction doc. So we did that, and then we came back with a spreadsheet, right, with the images and what items were found in there and locations of those items in the picture. So that was something that we could then put into AutoML to run, to create our own model. So it's a good example of some of that data pre-processing work. And once you do that, then you're ready to create your own model. AutoML natural language, let's talk about that. And by the way, I'm going to show a demo at the end, so you'll see the user interface and how to use these products. So AutoML natural language, just like I mentioned before with the image use cases, is what if you're trying to do something a little bit different from a standard use case? So here we're doing something like, say we wanted to take a description of a movie and get the genre from it. Just an example of a different type of problem using text. So to solve that, we looked at the movies data set on Kaggle that has a lot of descriptions, cast information, so forth there. And so we're able to create our own model that way. Another interesting problem with text that you can create a custom model for that's slightly different from the standard API is if you need custom sentiment. So there is out-of-the-box there is out-of-the-box sentiment that will tell you is this positive or negative, and it's using standard terminology, right? The corpus of information is general, language data that's used to train the model. But say you're in the airline industry here, you have specific terminology that has a lot of signal in it. So here, what we might do is, say we're looking at tweets or something like that, and trying to understand the sentiment of our service. We might say, okay, waiting on the tarmac would be a negative signal, so much leg room positive. So you'd go through your data and you'd start to flag these different pieces of text that could give you a more meaningful sentiment model from it. And then you're going to pass that into AutoML natural language. Another example of a custom model might be, here's our standard entity extraction where you can see that it has kind of general categories. It's correct. It says, Dale is a person, a cappuccino is a consumer good, but it's a little bit abstract in general. But we could create our own model, say that is trained on more specific terminology and can provide you more detailed information. So how you might do that, here's an example like of a menu parser where we're using AutoML natural language, where we're passing in different menus and flagging each of those, as to, is this food, is this a name, description, and so on. And with enough data elements, then you can create your own model to identify specific entities in your text. Here's just another example of that. And the final area of AutoML that I want to talk to you about is AutoML tables, which is for structured data. So the data that would come out of databases, tabular data in a CSV and so forth. So here's a fun problem that explains how to use something like AutoML. So Spotify has a data set here in Kaggle as well that has 80,000 songs and a lot of metadata around the songs. And, so if you use the API, you're going to come back with a specific, a song and then this quantitative data about the song, right? So you might think, well, AutoML tables, why would you apply that to music, right? Because we've actually done some interesting experiments around using AutoML vision where we take image data, convert it to images, and can do some detection that way. But if you think about it, that a song is going to have some elements of it that you can quantify, right? Like what key signature it's in, the loudness, all the things you see here, that different genres of music tend to be similar in these certain patterns that our ear recognizes, but we can train a model to figure that out as well. So that was an example of how you could take sort of a type of information that you wouldn't necessarily expect and put it into AutoML tables and be able to categorize it out of. So it was able to correctly identify music from these different genres. So let's take a more enterprise type of use case now. So this is an example problem where it's a marketplace where you're listing different items, and you see here things like the description of the item, the brand, and so forth. And the problem that the company was trying to solve is, as the user is entering the item, let's default it to a smart price point. And I actually ran into this the other day. We were selling our refrigerator at home, and I kind of had to look at a lot of ads and what were these older refrigerators selling for, and kind of had to make a ballpark guess. So this was trying to solve that problem of starting with a reasonable price based on all the other sales that had closed in the marketplace, right? So what you do is you add this information into CSV or a database in BigQuery, and then you're going to say which column am I going to predict, which is going to be the price sold column. And so one of the questions that people ask a lot about AutoML is, how well does it do? And I think that this was a really interesting experiment that answers that well, which is, Kaggle that I talked about before is a competition website where you have some of the world's best data scientists trying to solve problems over weeks to come together. They share their notebooks. They try to solve these problems and be at the top of the leaderboard. So you can see here that you start to reach diminishing returns. That as you get to about 1,000, the top 1,000, the error, that's what you see on the y-axis here, the error is not decreasing by very much. You kind of hit this plateau. So the minor improvements until you get to the very bottom. There's all the way to the right. So AutoML tables with 1 hour of processing time was clearly within that plateau. So it got an answer that with no domain knowledge, no extra processing of the data, and not nights and weekends trying to solve this problem, got to a very good answer. And you can see that you can specify different budget levels if you wanted to search a wider space of different parameters, different network types, to get even a better answer. So you can play with that dial around the budget you can apply to it. So that's an example of applying AutoML tables in the real world. And finally, the AI platform. I'm going to briefly talk about this so I have enough time for the demo. AI platform is where you can do custom model development. And so we have deep learning VM images. This is where you have everything you need, the GPU support, the frameworks, everything optimized within Google Compute Engine or VM environment. So it's a very, very easy way to get started with machine learning in the cloud. We also have kind of a related offering is our notebook offering, where we allow you to set up a new notebook server, which under the hood is really just one of these deep learning VM images. And then you have all the libraries there, and you can create your own model, code it up. And you don't have to worry about some of the complexities around reverse proxies and all that. It hides that from you. So you have your pre-configured VM image. You have a way to write your Python or R code or whatever you're wanting to do. Okay, so once you've created your model, we have serverless training, right? So here's where you can train models without too much infrastructure, worrying about all that. So we'll talk about that a little more detail. So when you create a model here, you deploy it into the AI platform, and you'll see it can be versioned, scaled. You have a lot of, basically all that infrastructure is hidden from you, and you get a REST endpoint. That's all you need to know, and you can monitor it, see if the model's drifting, and get some evaluation. So here's what we're seeing here. We're seeing as you're creating different models, you also have with Kubeflow and Kubeflow pipelines and TFX, which is TensorFlow Extended, the ability to compare your different model runs, kind of look at the accuracy between them, and really give you more of the reproducibility of your machine learning workflows. The final capability I wanted to mention briefly is around a pipeline. So I think that this is a very important concept, because we often spend a lot of time in talking about AI around building the model, right? Trying to get to that 99% accuracy or whatever target, but that's really the research element of this. So what we need to do here is think about reproducibility, getting the data from the original data sources in a way that's consistent every time, that that whoever's running this, the results are recorded, just like you might think of in the software development world. You might have a CI/CD environment where you're running your tests, or here you need to do the same kind of thing, validating the data coming into your model, validating that your model itself is not worse than the model that you had yesterday, to make sure that you're not creating a regression, that it's always improving. All those kind of workflow steps are critical. And so we do have that pipeline capability as well once you've created that model in the cloud. Okay. Yeah, so this all comes together with an open and fully managed infrastructure. So we have a few minutes for a demo, so let's switch gears to that. So the demo I'm going to show you is an end-to-end demo using more of the AutoML and the codeless approach to machine learning. So here's the data set that we're going to look at. So this is the reason I picked this data set. So this is looking at the Fire Department of New York monthly response time. So it's a publicly available data set, and it's fairly simple. It just has monthly data, types of incidents, like was it a false alarm, a medical emergency, what borough it was in, and their average response time. And so I picked this one because, again, it's easy to wrap your head around, and it requires a little data pre-processing. So if you remember, we talked about AutoML, you still have to tweak your data a little bit to get it in the right format. So here, for example, with average response time, that isn't going to work out of the box. What we need to do is convert that to seconds, for instance, and then you just have a nice numeric value that we can predict the response time from. And maybe we want to do some things like this bucket of all incidents or citywide, get rid of those, and etc. So basically, we might need to change a little bit of the data. So let's take that as our input. And the first thing I'm going to do is show you a little bit of the pipeline capability. So this is a product called Cloud Data Fusion. And this provides a kind of end-to-end pipeline capability where you have these various widgets that you can put onto your canvas. Here in the first step, what we're doing is we're pulling from a storage bucket. If you see here in the properties, we are pulling this monthly response time CSV. I simply just uploaded that from the website. And in the second step is the Wrangler. And this I think is a fun component, where this is where you're really manipulating the data in I think a fairly intuitive way. So let's go into this component and see how we wrangle the data. So say that I've left it sort of in its initial state here. So you just see the body column. So how are we going to start manipulating that? So I can click here under transformations and first start with parsing this as CSV. And then what I can say is, it's by comma, and the first row is a header, and click apply. And it might take a second to run here. Let's try Okay, let's try that again. Okay, cool. All right, so um, the next thing I want to do is, I'll just show a couple of these transformations. I won't do everything here in this demo. But say now we have this extra body column, we don't need that. So we could now just go ahead and delete the column. Now, like I said before, for a machine learning model, it's, mixing and matching the aggregate across all of the different boroughs along with each individual one doesn't really make sense. So I'm going to actually get rid of the one that aggregates all the different cities here. So I am going to then just do, like, say, a filter and remove row if the value contains citywide, right? And then, all right, good, it's gone. So I can keep applying these different transformations and apply it, and so on and so forth. So it's a nice way to kind of manipulate your data, directly from a database or different, data source that you see here. And then the third step I have here is putting it into BigQuery. So BigQuery becomes that central repository for doing your analysis and machine learning models. And here is where I would, take the different piece of the schema, say, which table do I want to put it in, the data set, and so on and so forth. Okay, and then what you do is you would save and deploy this, and it's going to create a Spark job. So it's all this nice GUI, environment you see here translates that into a scalable Spark job. It will set up an ephemeral cluster where it runs the job and then tears down the infrastructure when it's done. You can also point it to an existing Spark cluster if you want to do that as well. Okay, so then we'll show you BigQuery. So this is the data repository with all the information. We'll just do a quick example. If you want to query the table, you can use common SQL syntax, and you can see different results coming back. You can then save the results, do whatever you want with it. But just wanted to give you a very quick introduction to BigQuery. And then the final step, right, is now the machine learning part. So this is AutoML tables. Okay, so it's a simple, user interface with a few tabs. You start with, where do you import the data from? BigQuery or a CSV. I've already imported the data for this demo. The next step is training. And here is where it looks at the data you've given it. You can make some small adjustments to things like, making sure that this is correct. Is this a timestamp? Is this a set of categories, etc.? And then you see some data analysis. How correlated is it with the data I'm trying to predict or my target? So you see, 0.5, 0.4. That sounds reasonable. If it's 0, it might not be a great variable to include in your model. If it's a 1, it kind of might be cheating, and that there might be some leakage of information that is not kind of not helpful there in your model. So now let's look at some of the other different tabs here. Once we're ready, we're going to click Train Model. That's going to run for, say, an hour or two on a small data set like this. We get our model accuracy back, so you get different stats around this. So in this case, you'd see stats like the R squared. So that's saying that 80% of the variance of this model is explained, of this data is explained by this model. And you see the mean average error. So we're 9 days off on average, and the mean is about, 9 seconds off. And if you saw, each estimate was about 4 minutes, so not a bad model, 4 minutes plus or minus 9 seconds. And then you see in the evaluation something called feature importance. So each of the different variables in your model, it can tell you what made the most difference. So when I'm trying to arrive at that estimate, what in the data was the most important signal? So you see here, incident classification, what type of incident was number one, where it happened, and finally when it happened was the third most important thing. And these stats are across the whole data set, looking at that. The final thing, I know I'm running out of time here, is showing you the batch prediction. So I could pass it in here in the user interface, what I want to predict. I could also do an online prediction where I test it here in the user interface. I could put in an example value and see what I get back. And then finally, I had this idea of exporting my model. So I could, do all this training and then export it into a Docker container so I can embed that into my applications. All right, I think that's